In this video, we're going to multiply rational expressions. That's the next step after we simplify them, or a little bit harder than simplifying them. Now, remember that when we multiply fractions together, and now we're going to have fractions that are composed of polynomials, we're still going to multiply the numerators together, and then we're going to multiply the denominators together. Once I do that, then I'm going to simplify that result just like I did when I was simplifying in a previous video. And again, we're going to have to specify any values of the variable that's going to cause my denominator to become 0, because as I simplify it, some of those factors may drop out. So let's go ahead and try a few examples. And so here's my original multiplication. And what we have is, let's go ahead and multiply across. So when I multiply across, what we're going to have is we'll have 8 times 7 that's 56. Now I'm going to go ahead and leave it in factored form because that's going to be easier for me to see what the factors are. So that's going to be 8 times 7. I have x cubed times x to the 4th, so that would be x to the 7th. The exponents add. Y times y cubed, and the exponents add there, so I would have y to the 4th. In my denominator, I would have 2 times 4. I would have an x that's not going to multiply by anything. And I have y squared times y, so that's y cubed. Now let's go ahead and simplify this. And before we do, though, let's take a look at our denominator and see what values of the variables would cause that to go to 0, because some of the factors may actually disappear after I simplify. So what we can see is that we have an x here. That x cannot be equal to 0. So specify that. Also, the value of y would also not be allowed to be equal to 0. Okay, so I've specified my domain limitations. And now let's go ahead and simplify. So 2 will go into 8 4 times. Now this 4 will divide into that 4. Cancel those out. So what I have left is I have a number that is 7. And let's look at the x's. I have x to the 7th over x to the 1st. Those exponents will subtract, giving me x to the 6th. And lastly, I have y to the 4th over y cubed. And it would be the exponent of 4 minus 3, so I would have y to the 1st. And that would be my simplified answer. And notice how I have no variables in the denominator left, although I had them when I was multiplying, so I've lost visibility that I actually could not have x equal to 0 or y equal to 0, and so I needed to specify that. Next problem, so let's go ahead and multiply these. And what I'm going to do before I multiply them is I'm going to factor them. So what I could do is I could take, actually I'm going to factor them kind of as I multiply them. So I'm going to factor a 3x out. And that would leave me with x minus, actually that leaves me with 1 minus x. Then on the for the denominator of that, I'm going to have two numbers that add together to give me 4 and multiply together to give me negative 5. That would be x plus 5 and x minus 1. And when those multiply together, of course they're all going to form one big fraction. I have x squared plus x minus 20. Let's factor that. Two numbers that add together give me x and multiply together give me negative 20. That would be x plus 5, x minus 4, and then I have 3x. Okay, so now let's figure out the values that I cannot have in the denominator. So I would not be allowed to have x equal to 0. That would cause if this x was 0, my denominator would become 0. For this factor right here, x could not be equal to 1. And for the first factor, x could not be equal to a negative 5. Now let's see where my factors are the common factors. So I have an x, I have an x, I have a 3, I have a 3, I have an x plus 5, I have an x plus 5, And here I have an x minus 1, and I'm 1 minus x. So actually I can get these to be the same, so let's work on this for just a second. If I factor a negative 1 out of the 1 minus x, that's going to change the signs on both the terms in there. So what that would be is, let's put a minus, and that would be x minus 1. And let's check that. A minus times x is a minus x. There that is. And minus times this minus 1 would be a plus 1. So sure enough, that's the same. Then I have x minus 4. And in the bottom, I have x minus 1. And now I can get the x minus 1s to cancel. So my actual answer is going to be a minus x minus 4. Okay, the next problem. Okay, I'm going to go ahead and factor it and multiply it at the same time. Remember that this is going to actually have a 1 underneath it. So when I multiply those together, I'll have x plus 2. Then factoring the x squared plus 3x plus 9. That would be two numbers that add together to give me 9 and multiply together to give me add together to give me 3, multiply to 9, and right now there are not any that do that, so let's go ahead and write it like this. That's already factored. Now we have a difference of cubes. So remember, this a would be x, b would be equal to 3, and for the formula for that, remember that would be a minus b times a squared plus ab plus b squared. So let's go ahead and put those in there. So I would have a minus b would be x minus 3. Now I would have a squared, so that would be x squared plus 3x plus b squared would be plus 9. Let's go specify the domain. Where would the denominator become 0? And if you remember when we had a difference of cubes, that the part that has the squared term, that's always going to give us an imaginary 0. So the values of this that would create a 0 would actually be imaginary. So I don't have to worry about that. But for the x minus 3, I cannot have a value where x is equal to 3. So I'm not going to be allowed to have that. And let's take a look at what can cancel out here, and we can see that those will cancel out, giving me the final simplified form of x plus 2 divided by x minus 3. Next problem is, let's go ahead and multiply across. That would be 3 times 6. Now combining my x's, I have x to the 5th. That would be x to the 6th power, 5 plus the 1. And for the y's, I would have y to the 4th. On the denominator, I would have 8 times 9. Then the x times x cubed would be x to the 4th. And y to the 1st times y to the 1st is y squared. So we could see that the values of x that we can't have would be, this x could not be 0. This y could not be equal to 0. So let's go ahead and simplify. So I have this 3 would go into this 9 3 times. 2 would go into this 6 3 times, and into this 8 4 times. Now then these 3's could cancel out. So the only number I'm going to have left is a 4 in the denominator. Now for the numerators, for the x's, I would have x to the 6 minus 4, so that would be x squared. And y to the 4 minus 2 would be y squared. So there's my final answer, along with the domain. Next problem, let's go ahead and factor and combine. So I would be able to factor out a 2x, and that would leave me with x minus 5 times x plus 3 when the numerator is combined by multiplying, and the denominator, this is a difference of squares, x squared minus 25, so that's x minus 5, x plus 5, and then I have that times 2x squared. So let's find the domain. I cannot have a plus 5 or a minus 5, so x cannot be equal to 5. X can't be equal to negative 5, and this x can't be equal to 0. So I have this 2, and that 2 are common, so those can go. This x would go into that x there, and actually would just leave me with 1x. This x plus 5 will not be able to have any common factors, so it won't go anywhere, but these x minus 5s would cancel out. So I would end up with this, x plus 3, all over x times x plus 5. Next problem. Let's factor and combine the numerators. So I would have x plus 5, two numbers that add to 1 and multiply to 1. Well, those don't exist, so that would be my numerator. And my denominator would be the factored form of x cubed minus 1. So in this case, a is equal to x, and the b part is equal to 1. So what we would have was be a minus b, that's x minus 1. Then a squared, that would be x squared, plus a times b, that would be 1 times x, that would be plus x. And lastly, plus b squared, that's the formula for a difference of cubes. And the values that I can't have for x, would x not be able to equal to 1, or this factor would go to 0. The zeros for this factor are imaginary, so I don't have to list those. And my final answer would be x plus 5 all over x minus 1.